Okay, good morning class. So today we're looking at quadratic equations and inequalities. At this point there will be load shedding during your maths period. So I'm just pre-recording these examples so that I don't fall behind. Okay. So at this point we looked at exercise 2.9 on page 36, which was your algebraic equations there, your fractional equations. Okay, so at this point you are told that all the quadratic equations up to this point in this chapter have answers that are rational values or numbers, and therefore it has been easy to find solutions by factorization. So factors have had integer coefficients. There are, however, many quadratic equations where the solutions are irrational numbers, and it's not always easy to find the factors. We need to have another method to solve these equations. So what we've dealt with thus far is solutions or zero values that are rational, okay, which were nice values to work with, but that won't always be the case. So we're going to look at a different way of solving this, okay. So solving quadratic equation by completing the square. So completing the square was dealt in exercise 2.1 to 2.6. You can check those videos out. Also, the full lesson to this could be found in the description box below. The method we use so far in factorization, so that was the difference between two squares, and we find out zero values. There are two correct answers. You can check these answers by substituting these values back into the equation. So if you substitute x to be 4, you'll get 0, and x to be minus 4, you get the same thing. Now, here in this case here, we are showing you another way of doing it. We're taking that here over the equal sign. Remember, when we introduce square root, we must not forget plus minus, so x equal to plus minus 4. And this idea we're going to use in completing the square, as we're going to do in this lesson today. Okay, so we're doing examples, and this example 1 on page 37. Okay, this example 1 on page 37. And this is for exercise 2.10 on page 39. The first question is solve the equation x squared minus 15 is equal to 0. So we can go with difference of two squares and says x minus the square root of 15 into x plus the square root of 15 equal to 0, and then solve from there. Or we're going to just take that 15 over the equal sign, becomes x squared is equal to 15. The square root thereof, don't forget plus minus, so x is equal to plus minus the square root of 15. Okay. Okay, let's carry on. We get example 2, and example 2 is on page 37 as well. Here the question is solve for x. So as you can see here, this trinomial can't factorize as we normally do. Okay? So what we do is we treat this as if it's not an equation, because we have dealt with your completing of the square in expression form. So what we do is we complete the square on that trinomial. So it gets x squared plus 6x plus a number minus the same number minus 2 is equal to 0. Okay, so here's the coefficient of x squared is 1. So that's in order. So what number must be added to complete the square with here? It will be b times a half, and it must be squared. So it's going to be 6 times a half, which is 3, and 3 squared is 9. So this is your perfect square trinomial. So it becomes x plus 3 squared minus 11 is equal to 0. So now that is in the form of, as you can remember, it will be x into a into x minus p squared plus q, or you put a plus there. So now it's in the completing of the square form. But remember, the question was to solve for x. So what I do is I take that now over the equal sign. It becomes x plus 3 squared is equal to 11. Then I introduce the square root. If I introduce the square root, I must not forget plus minus. So x plus 3 is equal to plus minus the square root of 11. So x is equal to minus 3 plus minus the square root of 11. As you can see, the solution is irrational. Okay, so we can test it. Wherever we see a x, we put a minus 3 plus the root 11, so it's negative 3 plus the root 11. If I press answer, that's the last answer calculated. So it's going to be answer squared, which is x squared. I'm punching it into this formula then. It's x squared plus 6x minus 2, and x is in the first case negative 3 plus the root of 11. As you can see, it's going to give you 0. If I do it for the negative root, x is equal to minus 3 minus the square root of 11. It should also give you an answer of 0 if correct. Okay. This is another way of testing your solutions. If your solution is correct. Let's look at example 3. Example 3 is on page 38, the next page. Here we are told again solve for x. Again the coefficient of x squared is 1. So I can complete the square there. If it's not 1, I would have factorized or divide by that number there. So it's x squared minus 5x plus a number minus the same number minus 4 is equal to 0. And what's the number in question here? It will be b times a half, and it must be squared, which is 5 times a half, or negative 5 times a half, negative 5 over 2 squared, which is positive, so it will give you 25 over. Again, that is my perfect square trinomial. So that gives me x, take the sign of the middle term, which is negative 5 over 2 squared minus, and then in the calculator we put negative 25 over 4 minus 4. That gives you negative 41. Negative 41 over 4 equals 0. Again, that is in the form of a into x plus b all squared plus q, which is the completing of the square root. But the question again is to solve for x. So take that 41 over 4 over the equal sign. So it's x minus 5 over 2 squared equal to 41 over 4. Get rid of the square. I square root both sides. If I square root, I must not forget. Plus minus. So I got x minus 5 over 2 is equal to plus minus. If I put that in the calculator, it's going to give you the root of 41 over 2. Okay? You check this out. It will be the square root of 41 over 4. Oops. Square root of 41 over 4 gives you 41 over 2. What I then do is, to solve for x, that I get over, as you can see the denominators are the same. So that will simply be x is equal to 5 over 2 plus minus the square root of 41 over 2. Or I could have written it as 1, which would be better. That's the format the calculator will always also give you. It will be positive 5 plus minus the square root of 41 over 2. Again, if I take 5 over 5 plus the root of 41 over 2, that is equal to the answer. Just calculate. If I press the answer button, I should get 5 plus the root of 41 over 2. If I plug that into the quadratic, if I just highlighted it, will be answer squared minus 5 answer minus 4. Going to give me 0, which also means to say I'm correct. Okay. At this point, you can just pause the video. I'm going too fast. You can just follow through with your own calculation to confirm what I've just done. The last one is example 4, and example 4 is on page 39. The question says solve for x. Here we got the coefficient now in front of x squared. Okay, which is 2. So one of two things I'm going to do here. I can either divide by 2 or factorize the 2. I'm going to factorize the 2, although it's going to be a bit easier to divide by 2. I'm going to factorize by 2 because if it was an expression, that is what I would have done. Okay, so as I said, I'm going to treat it as an expression. And the difference with this sum here, it says corrected 2 decimal places. So the answer, we must then convert to decimal. Here it didn't specify, there it didn't specify. So you could have converted to decimal or left it like this. Okay. Normally they don't specify, leave it in what they call simplified third form. That is your third form, quadratic form there. Okay. So factorize it 2, because I'm going to do completing of the square on that trinomial. So it's 2 into x squared minus 5x plus 7 over 2 equals 0. Okay. So what we do is we must add a number to complete the square with, and I subtract that same number. And what's the number here? It's going to be b times a half, and it must be squared. Why do I say b? Because in the formula ax squared plus bx in standard form plus c is equal to 0, b is the coefficient of x. In this case it's 5, and 5 times a half is 5 over 2, squared is 25 over 4. There's my perfect square trinomial. That simply gives us 2 into x minus 5 over 2 squared minus, so you say 25, negative 25 over 4 plus 7 over 2. Okay, that gives you negative 11 over 4 equals 0. If that was the case with your cube, with your completing on the square, you of course multiply that out. I get 2 into x minus 5 over 2 squared minus 11 over 2 equals 0. So there we have completed the square there. But now to solve x, I have to take that over the equal sign as to isolate the first term. So it's 2 into x minus 5 over 2 squared equals 11 over 2. Now I divide by 2 both sides. Okay? So that is simply going to give us x minus 5 over 2 equals 11 over 4. It must be squared here. And then of course I'm going to take the square root. Don't forget plus minus. Whenever you introduce any even root, you go plus minus. Okay. So that will simply give us x minus 5 over 2 is equal to plus minus. That in the calculator is going to be the root 11 over 2. Of course I take that over the equal sign. As you can see, the denominators are the same, so it will be simply 5 over 2 plus minus the square root of 11 over 2, which is 5 plus minus the square root of 11 over 2. Okay. Now remember, the question says you must write it in decimal. So what I do is I put it in the calculator. So 5 plus square root of 11 over 2. This is the standard to decimal. So x is equal to 4, comma 1. And since that number following the 5 is greater than 5, which is 8, it will change it to 6. Or x is equal to, and I use the negative there, I just move my cursor, I don't type the whole thing in again. Because minus is the standard to decimal, gives you 0, comma 8. Okay. So that basically, anyway, of course you can check it again. That is the last answer calculated. Let's just plug it into this formula. This formula here should give me an answer of 0 if I'm correct. So I say 2 answer squared minus 10 answer plus 7. As you can see, it gives me an answer 0. If it gave me any other value other than 0, then that means to say that the calculation is then incorrect. Okay. So with that, you should be able to do exercise 2.10 on page 39. Okay. Tomorrow we're going to do the quadratic formula. You want to get the full lesson, it will be found in the description box below.